Okay, next the forecast model is the whole to winter's additive seasonal model. So like whole to linear exponential smoothing model we complete in the previous exercise, except that the level is adjusted for the seasonality, and then there is a third smoothing parameters, which is the now seasonality factors, right? To account for the seasonality. We can use the solver again to find the optimal value for alpha, beta, and the gamma here, right? And then we use this formula now, considering this seasonality. So where the LT is the level, TT is the trend, ST is the seasonality, and the P is the periodicity of seasonality, because it is periodically the changes the same is similar as seasonal factors, which means the same quarter of the other years, right? And then n is the number of period ahead. So we'll use this number of the number of the period ahead using the row functions later. Okay, then the same way we'll find the alpha, beta, and the gamma using the solver to find the minimal level of the mean absolute percentage error or the mean squared error. And then, okay, it's a little bit like kind of the augmentative. If you don't have the prior the period forecasted the sales, so inevitably we have to just simply use some other proxies or alternatives if we use this formula, right? So here, for example, weighted sales level, we cannot calculate yet because we need to get the same the quarter of the prior year, right? So that takes like 4 the other quarters. So here, now the starting point, the weighted sales level, the inevitably we have to use just average it. Okay, but it will not affect from then on, right? And then the next is now we can use this formula, right? Now alpha d5. We want to definitely fix this d5 function f4, and then times. Now next is the yt, right? Now here minus the seasonality of the same period of the prior year, right? So that's why inevitably we have to start from this formula from here, right? So now we have f13, which is the same quarter but the other years, the prior years. And then close the parentheses plus 1 minus, now the same, the alpha, which is not explained in the prior the period, right? So here close the parentheses. Oh, by the way, we need to fix, then multiply by now the level, and then plus the trend, right? So that we get the weighted sales level of the current period. So let's check before dragging down. Okay, so let's drag it down to the bottom. Now we have those the weighted sales level considering the alpha, the level, the smoothing factors. Now the trend here, even we cannot calculate the trend from fourth quarter, yeah, because we have to use the weighted sales level of the prior quarter, right? So here we need to start here. Again, what we are doing is this equation. So equal the beta, then fix this, then level. The difference between these two so that we can get the trend explained by the beta function, right? between these two periods at the sales level, the weighted sales level. And then let's close the parenthesis. Plus the 1 minus, again, the beta, which was not explained prior the period, which is now the trend here, multiplied by the prior, the quarter. Understand, right? So let's check again before dragging down. Oh, yeah, we need to fix this, right? Then enter. Then let's drag it down. Again, now moving to the seasonality, it's just again the proxy, right? But here we need to calculate the right formula. But before this, we need to use some proxy, the difference, some kind of seasonality, right? Seasonality. Out of four quarters, how does it changes, right? So we use just proxy the equations before using this, the seasonality formula. So how to calculate it? Now the actual sales minus pure sales level, right? So that we assume that that difference is the seasonality, right? And then let's drag it down only, yeah, this 1 quarter, right? Oops, we need to definitely fix this. These 4 other quarters of the year. And then now let's get started. The equation, application of this equation. So gamma now, which is the seasonality smoothing factors, we'll find using the solver. And we want to fix this now times 1 minus, here YT, right? Now we use this actual sales, right? This is 17 minus the level, right? The weighted sales level, considering considering the smoothing, and then plus now 1 minus gamma again. Let's fix this, and then times here the same the quarter of the prior year, right? So ST minus P is the same quarter of the prior year, right? Then let's check if this is the right equation that will apply in this the formula. Okay, then enter. So let's drag it down. Now we completed all these factors, right? Then let's calculate it. We cannot calculate here from here because all the factors we collected is from December 26, 2015, year 15. So here, now, here we can just add these 3. Oh, oops, my mistake. Here, dt plus nt plus st plus n minus t, right? Then, how do you get it? Sorry. So how to get it? Right, here, what we want to calculate is forecasting, right? Here, and then plus nt and ntt. So 16, and then plus the seasoner, right? The same the period end, and then enter. So let me check again if it is correct using this equation. We correctly apply this equation. I think this is correct. right? And then let's drag down. So now finally compared to the prior exercises, right? Considering seasonality, now it gets now very similar, right? It keeps tracks of the actual sales using this forecast of the model, big data model. Now, but we need to complete the forecast. Also, we need to complete the alpha, beta, and the gamma too, right? So first of all, using the forecast. Oh, so let's just calculate first the alpha, beta, gamma first. Again, go to the server. Now, the set objective in this case, mean squared error we use to minimize, right? And then changing the variable cells of these three, right? And then constraints of this, the variables is between 0 to 1. And then let's solve. So we found this, right? And then, okay. So now we found, oh, now we are very, the very similar, the forecasted the sales, right? Except for this period. Maybe the seasonality gets bigger. That's why this model couldn't follow exactly. But we'll make up this later in a different model. But anyway, now we got this. Now we want to the forecast this using the row function, right? So here, now again, we are going to use this formula, the same formula, but using the row functions, starting from now here, prior the quarter, the sales level, the sales level, because we don't have the next and next and next. Instead, we use this as a last number, right? So let's fix this, and then plus now E48, which is the trend, right? And then let's fix this, right? But here, when you calculate this n, which is the difference from the last actual the number here, right? Then we use now row function. Row function, open the parentheses. If we do not refer, then that explains just 49 row 49, right? Row 49. And then minus, again, the row function, open the parentheses. If we refer this, then, okay, this is also row of 48, right? Row 48. And then let's fix this because we don't have any further numbers here now. And then let's close the parentheses. And then we have to add here, right? The same, the seasonal, the factors of the last year in the same quarter, right? And then we don't fix this because it will drag down. So likewise, now we can, the forecasted next to forecasted is $122 billion, right? Now, finally, we get in this seasonality factors into our forecasting model. Now, once you drag down, now we have the second quarter, third quarter, the last quarter. When you compare this, it's very now the similar, right? Now, when you take a look this, the red line is the forecasted the sales, right? It moves the almost the same, right? The same the movement as the sales moved already, right? Then okay, I think we can use this, right? But if you think this seasonality factors gets like fluctuated like this, then we can also use the Holte-Winters multiplicative model instead of using the additive, which is the the differences. Instead, we can use the ratios, right? Ratio part. So let's move to this in the next the slide, next the video clips. We'll see you. Bye bye.